Good morning, ladies and gentlemen. Nez Porter at you. What I have is an assortment of switches. Now, I'm doing this demonstration because time and time again I find some electricians, but a lot of maintenance techs, they get these switches confused. Right now I have, this one is a regular single pole switch. So this two silver screws, single pole, single throw. So that's just like a regular on and off. It has on and off on it, if you guys can see it. So this would be the off, that should be the on. Now, not to confuse this one, which is a three-way switch. I don't know if you guys can see it, but one screw is different from the others. That black screw right there is different. Now, there's a reason for that. That's gonna be your pivot point of your switch. So that's like your common. Well, we won't call it common. We'll just call it the pivot point of the switch, because that's the one that switches goes left, right, left, right. But this is another three-way. Now, keep in mind of the orientation of the screw, because if you try to put them side by side, some of them don't look the same. That's what gets confusing. So if you're replacing this switch with this one, I don't know if you guys can see it, it's the black screws on the other side. So that's what confuses a lot of people. They think, well, take it off and switch it. Sometimes it works, sometimes it doesn't. But the most important thing you got to remember is which one came off the darker color screw. Now, the purpose of a three-way switch is to control the light from two different locations. Typically, the two brass terminals will be your travelers. This black screw will be either the power or to the light. And typically you put one three-way switch on one end, the other three-way switch on the other end. As long as you hook it up the right way, these two travelers connect with these two travelers. Think of a train track, and it's just switching lines from left to right, left to right. That's the idea of it. Now, they do make a four-way switch, and let me see if I have one. I don't have a four-way switch here. Oh, here we go. This is a four-way switch. So this four-way switch, this should have been a three-way. This four-way switch can go in the middle of these two three-way switches. So now you can control it from three different locations, and you can add as many four-way switches in between the three-way switches as you want. Because once you got the two, you only can put two three-way switches. You can't add any more than two three-ways, but you can add as many four-way switches as you want. Now, there's a couple of tricks to this. You could use this three-way switch to replace a single pole switch, but you can't use the single pole to replace the three-way. Now, let me tell you how you do that. If I just wanted to turn the switch on and off, I could pick the black and pick either one of these sides. And just remember that the three-way switch does not have an on and off. So typically you want the on to be up, off to be down. But the three-way does not have an on and off. The four-way does not have an on and off either. So that's something else to keep in mind. Now, if you don't know how the three-way switch works, you can always get a tester like one of these, and test the continuity. Now, typically what you do is you see if I can show you how this is done. Continuity tester, if I touch these two together, I get a beep sound. Okay, now that tells me I got continuity. Now, if I put a lead onto that common terminal, and I go over here, I got nothing. But I go over here, I got something. Now if I go over here, I got nothing. Over here, I got something. So that tells me that this thing is switching back and forward like that, back and forward. The four-way switch does the same thing, but it crisscrosses like this, like an X. It just crisscrosses like that. So this terminal switches over here, this one switches over there. That's all it does. So right now, if I go here, nothing. I don't got my leads on here the right way. Here we go. Oh, I'm not on there. Here we go. So, see, it just switches. Does the same thing over here. It just takes it and switches from left to right. Now, if you don't have a continuity tester, you can use an ohm meter. Ohm meter does the same. A cheap ohm meter like this will do the same thing. It just makes the ohm meter works the same principle. Give you a quick idea how that works. You take the ohm meter, you set it up on ohms, which is down here. You touch the two leads together. Am I in the right setting? Maybe you're not on the right setting. Maybe the battery's dead in there. And we on ohms? Yeah, it looks like we're on ohms. Maybe this thing is not working. I don't really. There it goes. So typically you zero in the ohm meter to use. You don't have to zero it out, but if you test in ohms, you gotta zero it out. So that just tells you got a full connection. And the same principle. You guys can see that, but that's the same thing. So once you've been working on these switches long enough, all you need to do is know which one's the live power and which ones are the travelers. Now the other biggest mistake I see a lot of so-called maintenance techs make a mistake of is this is called the GFCI, which stands for ground fault circuit interrupter. Two mistakes I see them do a lot. Now this happens to be a 20 amp. Now the reason why you know, or how you know it's a 20 amp, because you see a little T right there? That T is a 20 amp. If it didn't have that T, it'd be a 15 amp. Sometimes they put a 15 amp on a 20 amp circuit, which you're not supposed to do. And you could put a 20 on a 15, but you shouldn't put a 15 on a 20. At least that's what I was told anyway. The other biggest mistake I see them do is when you buy this and it comes out the box. See this yellow tag right here? Now if you're paying attention, that's the load side. The side that does not have the tag is the line side. Now, what's the difference between the line and the load? The line is the side that's coming from your panel. That's the live side. You cannot switch these. These are not interchangeable. The line side has to be on the line side. The load side is what's coming off the line and going to another receptacle or to a light or to where else it's going to. But you have to do it that way for the GFCI to work correctly. You have to put the negative on the silver terminal and the black on the what do you call it, the brass terminal. So black is always going to be on the smaller side of the notch. White is going to always be on the bigger side. And if this does not have the slots to stick the wire in, please put the hook going clockwise around the screw. I see time and time again people put it backwards and it's turning off the screw. It's not all the way on. Too much insulation sticking out on the side, all that craziness. Just follow instructions, take your time, try to do it right. And the thing that people mess up a lot, they don't ground this receptacle. This receptacle has a ground for a reason. The same as these, they have a ground for a reason. You're supposed to ground this. A lot of people say, well, I'm screwing it to the box, it's already grounded. Theoretically, you are, but they put this ground screw for a reason. They want this to be grounded as well. If you have a ground wire, ground it. That's about it for now. Don't want to overload you guys with too much, but if you're going to do electrical work, you need testers. Do not get that idiot stick. Do not use that idiot. Let me show you if I got my idiot stick over here. Hold on. I think I have it here. This thing here. This is, what is this good for? This is only good for telling you the presence of power. It won't tell you if you have a complete circuit. It won't tell you if your ground is working. It won't tell you if the neutral is working. All it does is tell you there's power there. Matter of fact, most of them don't even tell you the voltage. Like this one here just doesn't tell you the voltage. If I put this on, light comes on, it beeps when it's power. That's all it does. This is only good to know if you have power coming to a box. It doesn't even tell you if the neutral is even connected or not. So that's why I tell people, try to get a tester and learn how to use the tester. I use this one here. I had this one for years. This is the Fluke. It does what it's supposed to do. It tests AC and DC and continuity and ohms. I don't use all those features on it, but it has quite a bit features on it. They do got other testers that are better that test amps and all that kind of stuff, but theoretically, if you're an electrician, you're only testing for either continuity or electricity. Most of the time, you're not checking amps unless you want to see a amp draw on something. That's when you're doing like motors and stuff like that and get more technical. But if you come and do a troubleshoot, most of the time this bad boy here is going to be the one that's going to get you out of a jam. That's about it, guys. I will make more of these down the line. I'm not good at explaining things like this, but I hope I did a pretty good job. If I missed something, let me know. Oh, by the way, the four-way switch does not have an on and off too. So when you look at the four-way switch, it has 4 screws, but it does not have it on and off. So how you identify it is by the color of the terminals, because you can get the same kind of switch, which is like a double pole, double throw, I believe that's what they call it, and it looks just like this. So what it does is it's like having 2 of these in one. So it's like having 2 single poles in one. So if you see 4 screws and it doesn't say 4-way on it, it could be a double. What's it called? A double pole, double throw. Yeah, double pole, double throw. I believe that's what it's called. I could be wrong, but I believe that's a double Is that a, yeah, it's double pole, double throw. I could be wrong. I have to look that up because it's been so long since I looked at those switches. But GFCI, very important. Connected the right way. GFCI is supposed to be anywhere there's water within, I believe, 6 feet. If you're within 6 feet of water, inside or outside, you gotta have a GFCI. Basements, bathrooms, kitchens, swimming pools, all that kind of stuff. Anytime you're near water, you should have a GFCI. I think that's about it, guys. Until next time, I'm Nez Porter. I'll catch you on the next one.